Alright, so in this video we're checking out the Happy Model Moblite 7 HD Zero Edition. So you can see got the 40mm propellers on this one with the 1002 sized motors at 20,000 kV. But let's go take a look what's in the box first. Get your stickers, of course, spare canopy, spare set of props, get a prop removal tool and a screwdriver, get some spare screws here, 2 for the motor and 1 for the stack. This adapter cable for firmware updates that plugs to the VTX. And this is the back cover for the camera in case you want to use that, but of course they didn't use it to save some weight. So previously I reviewed the Mobula 6 HD Zero Edition, and basically it's the same quad. It's just basically on a bigger frame to accommodate the bigger motor and the 40mm propellers. So you go from these 31mm biplades to these 40mm biplades, and other than that everything else is the same. You get the same canopy, same camera, same obviously HD Zero whip light VTX. It goes up to 200 milliwatts, and you got the same flight controller for both of these. And in case you're wondering if you missed this video on the Mobula 6 HD Zero, I'll link that in the video description. Just for a reminder, this is how much it weighs. It's 23.9 grams. The Moblite 7, this is how much it weighs, no battery, coming in at 29.1 grams. I flew it with these 520 milliamp hour 1S GMB batteries with a PH 2.0 connector. Quad and the battery together, it's coming in at 42.6 grams. So like I always do, I fly it pretty much out of the box as it comes. No changes to the PIDs or anything. Something to note is that it did come with a very strange PID loop. It was at 0.08, I think, or 0.8, which is 1/4 of the full PID loop of 3.2 kilohertz. And it says the BMI 270 gyro on the flight controller. And I think they did that because of the way this frame interferes with the USB port. And you can see here the frame is actually touching the USB port right there, and it actually causes that part to bow out a little bit. So when you put the battery in here, you can see that the battery is actually pressing on the USB port. It's not a lot of pressure there, and it's also covering half of the USB port there as well. As you can see, you can get the thing to plug in. You'd have to kind of push this to the side. As you can see, it is able to flex and push out of the way, but I think it does put pressure on that USB port. I am a little bit concerned that that's going to break at some point, but I think that they have a very low PID loop to manage the vibrations, because obviously the motor's mounted to the frame here, and the frame is touching the flight controller directly through that USB port. I think the vibrations are getting through. They've done a lot of filtering and stuff, and also lowered the PID loop for that. So I think that it would be a good idea for them to rotate the board so that the battery goes in sideways and the USB port's coming out of the side here. And I did suggest that, but they said that the way this frame is, they can't get the motors to come through because the motors are directly soldered onto the board. So they solder on the motor, and then they push the motor through this gap here. And I think what they're saying is that they're not able to push it through this gap over here. But I'm thinking that this wire is long enough that you can still rotate everything 90 degrees, have the USB port come out over here and not touch anything, and not interfere with the battery, of course. That's the most important thing. And then you can still push the motors through this gap here and then remount them. So I will give that a try, and if I'm successful, I will post it to my Instagram. So if you want to see that, it'll be on my Instagram later. Because I think I do want to modify this a little bit, rotate everything 90 degrees, get the USB port out of the way, so it's not messing with the PID tune, and then increase the PID loop and basically get a better tune on this. I'll talk about that as well. So what I did was I just flew it out of the box as is. I already know at this size of motor, at this kV, and here's the look at the motor. And I already know that from my experience with this motor on, it was like a 75mm quad, that it has certain characteristics. It's gonna be kind of hard to explain. The way the throttle works. This one, it's very fast, and on the Bi-Blade, it's once you get above about 25% throttle, this thing is very quick, but it's not very responsive in the low end of the throttle. So it's good for like outdoor freestyle or like straight line flying really fast, which is what you're seeing here in the outdoor flight. I'm basically in the upper part of the throttle range most of the time, not flying very like precision, like in terms of precision flying or close proximity flying. I'm not really doing that here outside. So when I try to take this indoors, it doesn't fly that great because it's not, I think the way this was sort of conceived as concept is mainly as an outdoor sort of acro flyer. Now, the thing about this is as a freestyle acro flyer, it's a bit lacking in terms of top end power because of the voltage sag. It's caused by the PH 2.0 connector, and yes, it's still a solid pin connector, but it's not that this thing wears out. I think my batteries have started to wear out, so these don't have that many cycles on them. They're still in pretty good shape. They're not puffed or anything like that, but I'm thinking that the connector in here is starting to wear out on these batteries, and you know, I do probably should get some new ones just to do some comparisons if that's the case, because this connector on here is brand new, but I'm still seeing a fair amount of voltage sag on this motor with this connector. So if you do happen to get this, I think it might be a good idea to swap the connector out for something with the bigger pins like the BT 2.0 or the GMB 27, and then obviously swap it on the battery as well. Probably need to do some more experiments to see, you know, if I take this exact same battery here and I just swap the connectors to the GMB 27, what does the performance difference look like? So that's kind of a experiment I'm gonna maybe do in the future. I'm not sure if I have time for that, but let me know if that's something that interests you. Of course, if there's enough interest, if there's a fair amount of interest, then I might take up that project, but let me know. Yeah, but basically, as it comes out of the box with the connector it has, if you use these PH 2.0 connector batteries, the voltage sag is pretty significant, which hinders its top end performance in terms of trying to do like power loops and MADI flows, that kind of stuff. It's pretty hard to control that power at the top end because you get that burst, and then all of a sudden you get a voltage sag, and the power isn't there, especially if you're trying to come out of some of those maneuvers and you need that power, you need that extra power, and you don't, and you end up actually hitting the ground. So I do end up crashing quite a bit. Yeah, but this is actually pretty decent in terms of crash durability. I crashed it quite a bit, especially indoors. And yeah, I should probably talk about that. When I'm trying to fly this indoors on the stock settings, I had a very difficult time. Just basically because in my opinion, the kV of this motor is so high that it's going to generate so much more speed indoors that flying in a smaller, tight space like I'm trying to fly inside my house is virtually impossible. I think that if you're a super skilled racer, you might have a better luck than me, but the main issue is the precision of the throttle at the low end of the stick. So when I'm flying this, this is my controller here. And by the way, this is I'm actually flying everything through a screen. You probably will see that in the video. I'm flying. I just put my receiver here on the back of the screen. Someone had asked me to fly more through the screen or a smaller screen, because I flew through a big screen last time, so I'm flying this through this like little small 5-inch screen here in all the flights. But anyway, when you're dealing with the throttle at 20,000 kV, so anything above like about this point in the stick, it gets so fast that it's uncontrollable, and there's no resolution at the bottom end of the stick. So all your precise maneuvers are in this sort of little tiny area of the throttle. So what I ended up doing is to get more throttle resolution here at the bottom end of the stick, where you're trying to fly slowly and like go through obstacles and stuff like that. What I did was I put in a 50% motor output limit. So basically effectively reducing the kV from 20,000 kV to 10,000 kV, which then instead of having, this from 0 to 10,000 kV being here, 0 to 10,000 kV gives me the full stick here. And so I have more, basically double the resolution down here at the bottom. So when I'm down here before, now I have this much maneuverability in the stick to make more precise movements. I also put in a massive throttle curve, so I put those up here as well, and also added a VBAT sag compensation. That's one of the settings you can put in there that'll kind of smooth out, especially at the end of the flight, what the voltage is like and how much throttle you're going to have at the end. So once I made those changes where I reduced the motor output limit to 50% and then put in that big throttle curve, I felt that I had a lot more precision in the bottom half of the throttle and was able to fly in the smaller space more confidently with less crashing. So if you're having that problem, if you're flying in a small space, or if you're having trouble controlling this in a smaller space or around like a lot of obstacles, this is what I would suggest you do, is basically get that motor kV down and put in a big throttle curve to get that throttle resolution or that precision down at the bottom of the throttle, so you have more control of it in a tighter space. So that's what I did, and it actually helped. So I'm passing that along to you in case you're having that problem. That should help you as well. Now, in terms of flight time, I was getting about 3 minutes, maybe a little bit less depending on how hard I'm flying on these 520s. But basically the first 2 minutes are pretty good. The last minute, between 2 and 3 minutes, the battery voltage is kind of low, so you can't really do any punch outs or anything like that. So you're kind of limited to just sort of flying in like a racing style and like a straight line, that kind of stuff. Now, when I actually reduced the motor kV to 50% and flew more precisely and slowly indoors in a smaller space, I actually got more flight time. I actually bumped it up to about 3.5 minutes of flight time on the same 520. Another thing to note is, because of the way the USB port is kind of blocking and putting a bow in that bottom part of the frame, I wasn't able to try any other batteries besides this one. There is a 450 milliamp hour 1S that's the same dimensions, but it's just a little bit, it's not as long as this one, so you can try that one if you want. It's just so you're going to get a shorter flight. I didn't actually test any of the 450s. All the 450s I have are pretty much dead. These are actually newer, so obviously I want to go with the better batteries so that I could get a better sense of how this performs. But yeah, it's pretty much it in terms of this one. It's basically the same thing as the Mobula 6 HG0, just the bigger motor and the bigger prop and bigger frame. But I think that some modifications could be done here to improve it. Like, I think that what you would want to do is get this USB port out of the picture here, change the connector. I think you're going to definitely see a lot of improvements there. I think the biggest thing in terms of the flight time, in terms of the flight time and the battery life, is the HG0 VTX does eat up a lot of power. I suppose if you want to avoid this whole battery tray here, you could cut this off and use a 3D printer part or something like that there to go with bigger batteries. But of course, you're also at the same time going to be carrying more weight around, so some people will trade the overall heavier weight for more flight time, and that gives you like a little bit less acro ability in terms of like doing tricks and stuff like that. So it's all trade-offs, of course, and kind of what you're looking for. But yeah, it's I think there's a lot of potential here. I'm going to keep working on this one here, and if I get that board shifted around, maybe I'll make some other modifications. I'll let you know, either in a future video or on my Instagram. So that'll cover for this video. Let me know if you have any questions. Talk to you guys in the next one.